Hello everybody. Today we are going to discuss GLM-5. This is a new open weight model released by the company ZAI. They have been releasing really good models for the last 8 months. I've run a lot of them locally. I've also worked on pruning and quantizing them for the open weight community, and you can see that on Hugging Face if you have to compute for it. I was able to get it to run on a MacBook, which I'm very happy with. This model is excellent. So this is their latest version. It is built on a new architecture. It's also a lot larger. And so that comes with pros and cons. And the pros in this case are that it's much better at programming, significantly so. And it is the top open weight model as of now, and the fourth best model in general. They have really, really good infrastructure built out, and they let you use these models with Claude Code, Open Code, all of the little extension plugins in VS Code, as well as just via their API. And the cost is pretty cheap. So their subscriptions are famously $6 a month, and for the lowest tier, which gives you about the same usage as you would get with the $100 subscription of Claude. So we are going to be testing it in OpenCode and in Parchy. The reason I want to also show out Parchy is because I think that this model is going to do a very good job at working within a browser, given that they score really high on browser comp. Now, I'm going to try to treat this as a normal workday for me, so this video is going to be a bit difficult to follow along with, but hopefully this gives you an idea of how this could fit into your own workflows and what you can do from there. Please make sure to build. Okay, it actually did build. I don't need to send that out. So we are going to go in and use the tooling that I have been working with. So Parchy is a browser extension. I built it as a response to to Claude's Chrome extension, specifically because for some reason Claude's Chrome extension has been locking out of different sites, so you're not able to use it with like Stripe, just as an example. I don't like that. I want my LLMs to control these sites for me. So here you can see that I have GLM-5 set up. I'm going to try and increase the size of the text so that it's a little easier for you guys to follow along. 110 is good enough, and we'll go from there. So I want you to do deep research on all of the current quantization methods that have not been applied in any of the frameworks like GPTQ, AWQ, specifically focus on new research papers from the year 2025 to the year 2026, and try to get me 5 good examples, put them in a table for me, and please give me the rundown, like description of what they are and what they do and how they work, and whether or not we can implement them and use them with something like VLM. So now what I'm doing is I am giving the LLM a task, which it is going to hopefully, if we're not mistaken, perform it well on the browser. So it's going to be able to jump around the different sites, do some tool calls, read some papers, scroll around, make a plan, as you can see here. And I typically use this for various reasons. One of them is scraping. So if you're not aware, like these LLMs are pretty good at controlling a browser. Not just this one, but a lot of the top models can control a browser pretty consistently. And what that unlocks is the ability to access websites like Twitter or LinkedIn that wouldn't necessarily have open APIs. And you don't have to use this for anything malicious, but generally speaking, the purpose is that it can interact with things that it can't via an API yet. And that gives it access to knowledge and information that you can then distill into whatever it is that you're trying to do. And this is a common thing that I've been doing over the last few months, is sending these LLMs out to go and do research for me so that they can find what is relevant, what's new, and opportunities that I could personally apply, which is very exciting because you can just take a research paper, drop it into Codex, and come back in an hour. So this is going to take a long time. One of the few flaws of this model is that it does not have vision. And then another thing that it struggles with is speed. So given that this is a new architecture, this is called the DSA architecture. So we can take a look at, so this is DeepSeek. DSA architecture is like a new way of handling the context window. It requires very specific chips and very specific kernels and all of these like different things that haven't been applied at scale yet, which means that this lab is right now struggling probably, one, to be able to feed the demand of all these subscriptions that are coming in, which makes sense because it's super cheap and it's very good. While we're doing that, we're going to jump in and try to go here and let's talk to VLM Studio. So this is the website VLM Studio that you're looking at. This website here is very useful for me. It lets me manage my open weight models. So I've been building it out over the last few months because I've run these 8 GPUs locally, as you can see. And one thing that I'm struggling with right now that I actually need Claude's help with, please make the KV cache FP8E underscore 4, FP8E4 underscore M3, and please put 200K context window. Once you're done, I need you to figure out how to show me what version of VLM I'm running on the dashboard, as well as what version is the model itself running. There you go. And what we're going to do now is we're going to take that 8 away and we're going to take this away. So I use voice mode a lot, and this is one of the things that I do use Claude for pretty consistently. It's configuring my settings. So I'm seeing it here. Yep, there you go. So it's starting up the server, and this is the last thing we're going to do with Claude today. The rest we're just going to try to stick to. We are going to stick to our open code. So let's start with VLM Studio. What I want to do is, can you please add a section in the configuration that allows me to configure providers like Anthropic providers, OpenAI providers, and the responses API providers? Basically, this is not configuring the backend. This is configuring other providers so that I can add models that are not just local. This is a UI only functionality. You will need to basically scope this out and give me a plan that you are going to follow. So what I like with the GLM models is that they are pretty good at doing this like work that's crunching. So it basically will read a bunch of files, it'll find interesting things, and it'll come back and it'll write you documentation. What I don't like about this right now, given that this is a video, is that it is so slow. And the reason I bring that up is there's like two ways of working with these LLMs. One is the OpenAI Codex way, and I would say also the GLM way, where you scope things out up front, or you have a conversation with the model, you get to a point where you have good information for it, you send that, and then you walk away from the screen for like 2 hours. And the models are typically very good at that. Connection lost. Well, this is the issue right now that you could see as well that I have been struggling with over the last day. But at least it's working. It basically shut down my connection over there to communicate over here, which is a little bit disappointing. They need to be able to scale their infrastructure for this to be super viable right now. While this is working, I'll demonstrate the second mode of functionality that I think is good. So you can see here that we have OpenCode Cerebrus plan, and the model under the hood is GLM-4.7. So this is a model that is made by the same company as Zed AI, but it is inferenced and served in a very specific way, and they are good at like specific types of tasks that are different than this give a big scope and walk away. So let's think of what we can talk about. So I want you to tell me, let's not do Ralph right now, or let's do Ralph. I want you to find me all of the errors, type errors, any's in this repo, anything that is undefined where we are not handling the types correctly, and please report back to me with a matter of priorities. And so the second type of work is where you work very quickly and iteratively on a task, and And this is serviced by, like I said, there is the Codex Spark model now, which I've been testing over the last few days. Maybe I'll make a video about it. It's really good, but it has its own way of working that is special to it. And the same with this GLM 4.7 model. So you could see that it is very quickly doing the tool calls, very quickly doing the reviews, and then coming back to me with a plan and a priority list. While when we go back over here, we can see that this is still rating files, right? It's only made like 3 tool calls. It's going to sit for a bit. The latency is killer. I think it's running at like 15 to 20 tokens a second. So if you were trying to buy the ZAI plan to replace basically your Claude Code experience, I don't think that that's the right thing to do. I think you should think of this more as its own type of model and then figure out how you can work with it specifically. A project that I gave it very recently was a very, very large, well-defined scope and task where I told it I have a DigitalOcean droplet and an AWS server, as well as a Hetzner server. And I had these configurations spread over these 2 services, so DigitalOcean and Hetzner. So I had servers running back there, a lot of different stuff that I needed to migrate over for an old client. And what I needed to do was basically tell the model, like, here's where things are, here are the keys that you can use to access it, and here is the end result that you need to demonstrate. And I gave it a link to a website. That website was like where the final results of all of this infrastructure was. And I needed it to be able to sign in. I needed it to be able to like click a few buttons and make a few queries and get things working properly and show me screenshots to prove that it did a good job. And so I left it and I came back 2 hours later and it was still running. But when it was done, which was in another 30 minutes from there, my entire infrastructure was completely moved over from Hetzner and DigitalOcean onto the AWS service. And so this is like a pretty complicated migration that would have probably taken me a few days to do by myself, realistically speaking. This model was able to do it much quicker. I had access to a faster version of this. It's the same model, but it was faster, which helped a lot, but it wasn't that much faster. It was maybe 2x as fast. But you can see here that the fast one is still going and looking for undefined types, but it has probably read at this point like a lot of, you can see how many tool calls and how much reading it's done. This is a lot to sift over. This is the open code repo, but with the Cerebras. So it's the Cerebras code, which is a fork of the open code repo. And you can see here that it is running really quickly and nicely. While that is happening, I would like to go back here and I want to do Cerebras. Okay, that's going to work. So while that's running, we are going to switch over to GLM. So Cerebras is GLM 4.7 to keep demonstrating how I would work with this. I don't like the way we are using let's say I'm gonna try to use my voice, which is how I would actually work. I don't like the way I don't like the way the composer is colored. Like the highlight color around it when I click and type something is very overwhelming. I would like it to be extremely subtle and extremely like thin. Another thing that I don't like is how everything is sitting inside of cards. Like the model think blocks are inside of cards. The tool calls are inside of cards. I would rather all of that be like in a single layer. It should be collapsible, but it doesn't need to be in a card. Maybe we highlight it differently. We add some indentation to it. Please, before you make any changes, make me three different mockups in HTML and CSS of how you will make the side panel look, so I can cherry pick what I'd like. So now the real combination a lot of the time ends up being that you have a fast version of a model that is going to go and explore the repository for you. It's going to look around, it's going to find information, it's going to create, let's say, demos for you. or mock-ups for you so that you don't have to spend so much time iterating later. Also, the smaller models can do like very localized coding really efficiently. So we will demonstrate this back in VLM Studio in a second. Let's see, we have 4 errors here. I'm going to try to look. Okay. And let's see, I will try here. Let's open another one. And let's do Cerebras CLI. I'd like you to please go and find all of the errors and warnings in this repo and let me know, or actually, let's do something else. Instead of having it do that, let's do in main controller source, we have this error, a parsing error. ESLint was configured to use this, and that. Can you tell me what it is and how we can fix it? And so what's going to happen now is that it's going to go and identify this and basically fix it like very, very quickly. Zed also is great at demoing this because Zed lets you do in single file edits. Hopefully I still have the, let's see here. Hopefully I still have this connected. Where is the inline editor? To agent thread. I forgot how you do it. I think it was like something like I forgot. That sucks, but that's all right. I'm going to leave that alone. Now, the problem is that with fast models, so the same thing with the GLM fast models, is typically they go so fast that they just destroy all your credits. They use up all your credit usage, and you will be left waiting and hitting sometimes you're going to be hitting, what are these called, like cooldown periods. And with fast models, both like in GPT, for example, and in Cerebras, I've run into this a lot. But when it does work, it's great. Like I love the ability to just basically give it a task and then very quickly have it go over and clean everything up. So now it is still working, but it has gone through so much code. That is a lot of code. Holy man. We're going to go back to the larger version and take a look at what it's doing. Now it's still reading. So hopefully this gives you an idea of what you would be getting into. I think one more thing we can do is, it's interesting. I don't understand why this is at 0 usage. Let's do a benchmark. Okay. Let's do a benchmark. Unable to connect. Let's see. I'm having an issue where I am unable, like GPU 2, while there is data in it, it is empty. Like it's not actually doing anything. What's the problem? And let's go hit it with this. And let's go back. So it's still checking stuff, but it's parsed through a lot. And let's go over here. Tokens per day limit exceeded. Yeah, that's what I dread over there. And this is still thinking. So one more thing I'll go over is the actual. So when you're running like GLM 4.7 specifically, you will have like a pretty decent experience in terms of speed. It runs like at a very acceptable speed. And so I think long-term that this is a good investment and it's going to do really well for a lot of people. It's $6 a month, up to like $15 a month if you want the full like Pro, which would be 5 times more or whatever that what Claude gives you. Now, it's very unlikely that you're going to hit those limits in the first place, but it does give you the ability to do that. So if you're running a lot of long running tasks, also if you are working with the team, you can use the concurrency limits in there to allow it to run, a few people can use the same subscription without hitting your rate limits, which I have also enjoyed in the past. Now, I hope this gave you an idea of what you would be getting yourself into if you would pay for the subscription. None of them are perfect. We can also take a look at MiniMax-M2.5. Hopefully I have it in here. I do. Let's take MiniMax-M2.5 and let's basically MiniMax. I don't like the way that this agent does coding. It's just very, very slow. I think I would rather if we can build out a coding feature that is similar to the OpenClaw like coding agent slash command. Can you look at that on the web and then come back to me with a plan? Scan the repo and make sure you understand it well. So the end goal is that the main agent that we talk to is able to run Codex, YOLO, Claude, dangerously skip permissions, Droid, Pi in its own like environment, and then feed us back the results later without having to code itself. So just scope it out. Don't actually build anything yet. And so an example of like other models that are similar is MiniMax is like it's in a similar bracket. It's much cheaper. It's a decently good model, but the difference with MiniMax is that it is typically much faster. Now I don't know why it's so slow right now. Maybe this is an issue with my configuration. So let's try to do Pi and demonstrate this. MiniMax-M2.5, and I'm going to copy my prompt. Okay, it's working here, but I think this is going to be much faster. So I'll see what happens when you run two of them side by side. And this is running at probably like 50 tokens a second. I am very excited that I will be able to run this model locally. I have actually run it locally so far, but it was pretty slow because I was using GGUFs. And so look forward to that. I think one thing I'll leave you guys with before I head out for the day is I want to prune and quantize the GLM-5 model. So I'll try to like demonstrate what I mean by that and how that could work. This means your monitor is connected to in the desktop compositors using VRAM there. When VLM tries to allocate memory equally across GPUs. Okay. Just fix it. This was not a problem like a day or two ago. Please just fix it. Okay, it'll figure itself out. It's running 4.5, which I prefer. I much prefer the 4.5 version of Opus. What I want to do is take a large model like the GLM-5 model. I'll show this right now. ZAI.org and GLM-5. So what we can do is take this model. It is 750 billion parameters. We can prune it. So by pruning it, we can basically take half of the model and chop it off. And the way we determine what half of the model to chop off is by running these things called observations against the model. Once we run those observations, it'll tell us like these are the bits of the model that activate the most for your specific use cases. And what you can do, which would be interesting, is running the AI, where is it? My GitHub Oxero. Yeah, this is going to be a little bit slow. You can take one of my scripts that I've written, AI data extraction, and you can allow it to go and find all of the different AI chats on your device and pull them together and turn them into training data, which is just JSON-L format. I've used this, I've trained my models with this, and I've also used this for pruning and quantization, and it does wonders in that you can have it take a very large set of data. You can take it in, you can organize it, and then you can give it to the model, and you can watch what's happening with its weights, like when they're activating. You can monitor that, and once it starts activating and everything is working right, you can then take that and then you can also quantize it, and that'll give you a model that is like 20% of the size of the original, which 750, so 20% would be something like 150, and then you can run that on much smaller hardware. It's obviously not going to be as intelligent, but for the use cases that you specifically pruned around, it's going to maintain a lot of its intelligence. There are going to be some boundaries that you hit with it where it kind of forgets things. Like for example, if you ask it like about a certain topic unrelated to coding, it might work for a bit, but then it just crashes. And what I mean by crashes is just repeats itself. And this happens not out of a mistake of the developers, but mainly because it just cannot make the next statistical decision. So you can see I've done this successfully in the past. If you're interested in something like this, maybe you can reach out to me on Twitter and we can talk about how to make this work, because I think it could be very, very cool and very fun to get GLM-5 running locally. Thank you guys for watching. I will see you in the next one.